Imagine trying to teach a computer to spot skin cancer from images. Sounds tough, right? But here's the thing. Real-world data is limited, and some skin conditions are super rare. That's where synthetic data comes in, artificially generated images that help train AI models. But not all synthetic data is created equal. Let's break down a study that shows how smarter synthetic data can make a huge difference. The researchers tested 3 approaches. 1. Real-only data, just real patient images. 2. p-SOTA, a previous synthetic data method. 3. Their own method, LesionGen-R B, which uses rich, balanced prompts to generate more realistic and diverse images. They evaluated these methods on 2 datasets, D7P and HAM. The key metrics: overall accuracy, how often the model is right, and per class precision, how well it identifies each specific skin condition. Looking at the results, their method shines. On the HAM dataset, for example, their model achieved 75.6% accuracy, way better than the 58.7% from the old synthetic method. But here's what's even cooler: underrepresented classes like DF. A tricky skin condition saw a massive jump in precision from 0, real only, to 0.418. That's like giving the AI a better chance to learn the rare cases that matter most. Now let's talk about why their method works. They didn't just slap on random labels. Instead, they used concept-guided prompts. Think of them as detailed recipes for generating images. For example, instead of saying melanoma, the prompt might describe dark, irregularly shaped lesions with uneven borders. This helps the AI grasp the clinical context, not just the label. But here's the kicker: synthetic data alone isn't enough. In ablation studies, when they used only synthetic images, performance dropped. However, when combined with real data, their method outperformed everything else. They also found that balancing prompts, making sure rare classes get equal attention, prevented the AI from favoring common conditions like NV, NEVI, which are more frequent but less critical. So what does this mean for the future? Better synthetic data could democratize access to high-quality medical AI, especially in regions with limited data. And their techniques, rich prompts, class balancing, could revolutionize how we train models for rare diseases. Next time you hear about AI in healthcare, remember, it's not just about data volume. It's about smart data. And that's what makes this research so exciting. Want to see what these synthetic lesions actually look like? We'll show you the images and why they're a game changer next. Stay tuned. Now let's zoom out. How did we get here? The breakthrough hinges on diffusion models, a type of AI that learns by reversing a process of noise. Imagine taking a blurry photo and gradually sharpening it, step by step. That's essentially what these models do, but with medical images. For example, the 2020 paper denoising diffusion probabilistic models laid the groundwork by teaching computers to reconstruct clear images from noisy data. This technique has since been adapted for specialized tasks, like generating realistic MRI scans with PathoLDM, 2023, or translating medical images between modalities using Med-SegDiff, 2025. But how does this translate to real-world impact? Take Med-SegDiff, 2024, which uses diffusion models to precisely segment organs in scans, or PathoLDM, 2024, which generates histopathology images from text descriptions. These tools aren't just about accuracy. They're about enabling doctors to see what's invisible to the naked eye. What's truly exciting is how researchers are combining techniques. A 2023 study showed that augmenting medical image classifiers with synthetic data from diffusion models boosted performance, while others, like 7-Point Checklist, 2018, used multitask learning to tackle multiple skin conditions at once. It's a blend of creativity and precision, where AI isn't replacing doctors but empowering them. From the HAM 10000 dataset, which houses thousands of dermatoscopic images, to Chest X-ray 8's hospital-scale X-ray library, these resources are fueling breakthroughs. As we've seen, the best results often come from pushing boundaries, whether it's refining generative models, improving segmentation, or leveraging multimodal learning to combine text, images, and clinical data. So what's next? LesionGen's approach isn't just a technical win, it's a blueprint for equitable AI. By bridging the gap between limited data and clinical expertise, it opens new possibilities for research and patient care. And who knows? Maybe one day, this technology could help doctors spot diseases earlier or even personalize treatments. Thanks for watching. If you're curious about how AI is reshaping medicine, hit subscribe for more deep dives into cutting-edge research. And let me know in the comments, what other medical mysteries would you like to see solved with AI? Until next time.